In this lesson, we're going to talk about defining and calling simple helper methods. So we've been consuming methods since the very first lesson. I may have even referred or used the term method several times prior to this. I definitely referred to event handlers, which are a type of method. But simply put, a method is a named block of code. If a block of code has a name, well, then you can call it by its name and you can execute the code inside of the code block. Okay, it's as simple as that. And you use methods for a couple of different reasons, private helper methods for a couple of different reasons. I'm going to make a distinction between private helper methods and a type of method that you'll see a little bit later on when we get into classes, which are public methods that are exposed to other classes. But let's hold off on that. We're just talking about private little helper methods. There's just a couple of reasons why you would ever use one. First of all, you'd use a helper method or create one whenever you see the same code required in 2 or more different places. So you have 2 lines of code, 3 lines of code, maybe 10 lines of code, and you find yourself copying and pasting that code, or you see that there's very similar code blocks here and here and here in your code. That should be a signal to you that, hey, I might need to extract out all that code and put it into a method and then call that method with 1 line of code, 1 simple little call using its name to execute that code block from wherever in my application I need it. Okay, so that's number 1. You use it whenever you need the same block of code in 2 or more places. And then secondly, you would use a helper method whenever you have a complex problem that would benefit from being broken up into smaller problems, all right? And there's an old programmer saying that your code should read like a story. In other words, if you do this right, if you have a big complex problem requiring 20, 30, 50 lines of code, if you have all that code in one method, it becomes very monolithic. It becomes hard to read and hard to understand. But if you split it up into smaller code blocks and give each of those code blocks a name, a descriptive name of what that code block is attempting to do, then you can read, like it may only require 4 lines of code, 4 calls to helper methods, each of those helper methods containing a couple of lines of code that do something very, very specific. All right, so here we have an example of a candidate that's just primed and ready to refactor, which is a term that means I'm going to improve the quality of the code by simply changing up the way that it's structured, the way that it's written to make it more compact, more readable, perhaps even perform better, definitely more maintainable. Okay, so that's the term refactoring. So this is a candidate for refactoring, and I'll explain why in just a moment, but you can catch up to me. This is the CS-ASP_028 project. You should be able to download that. You know the spiel. I'm not going to go through that again. But if you take a look at this little project here, and actually let's run it so we can see what it does. It's a simple application. It just basically converts anything you have, like 8 quarts, into a number of different cups. So how many cups are in 8 quarts? Well, 32. All right, so the simple application, right? But the complexity comes in whenever you take a look at some of the features that I've actually implemented here. Did you notice that there's no submit button, no OK button? So the first feature of this project that I want to point out is that each of the radio buttons as well as the text box have a property turned on, and that property is called auto postback. So let's find it here on the text box. Yes, here it is, and we've set it to true on the text box, and we've set it to true on each of the radio buttons. So what does this do? Well, whenever we make a change or select a new radio button, or when our mouse cursor leaves the text box, there will be a postback from the client to the server, at which point we can handle that particular event. So for example, if we were to select the cups radio button, you can see that the checked changed event fires. It will force the browser to submit the form, the web form, back to the web server for processing. The same is true with our pints radio button, notice that it has a checked changed event that we're handling with this from pints radio _ check changed. And then the quarts has check changed and gallons has the check changed. And each of them are firing off different methods, or different event handlers rather, okay? Same is true with the text box. Notice that the text changed event here is set to quantity text box _ text changed, so that whenever we make a different selection or move out of one of these server controls, it posts back to the server. All right, so simple enough. That's the first thing that I wanted to point out here about this project. Also, as you might expect, each of these checkboxes belong to the same group. Let's see if we can find that here again. Scrolling down. Oh yeah, this is the from group, okay? I have a reason for the naming. It'll come in handy a little bit later. But at any rate, what happens then whenever we select a different radio button and the form is automatically posted back to the server? Well, here we have a number of event handlers, and they all follow kind of the exact same pattern as you might expect. So let's take a look at the from pints radio _ check changed event handler. The first thing that this does is it checks to see if there's anything in the text box. All right, so if the text box text property, and then we call this trim method, which we'll talk about later whenever we talk about working with strings, but the trim method will essentially trim off any empty spaces or any space characters before and after whatever's been typed in. So if I hit my space bar, space, 7, space, it would just remove all the spaces and just give me the text value 7, okay? Then once we've removed all the extraneous space characters from our text property, then we're going to measure the length of it. This is how many characters are in our string, in the text property of our quantity text box. If it's equal to 0, that means they didn't type anything at all. So we're going to just return out of this method. But suppose that we did have something typed in. Now we need to ensure that it is a numeric value. In fact, that it actually converts into a double. And so I have taken another step of ensuring the success of the application by using this double dot try parse. Okay, so we've used double dot parse and passed in a string, but what if somebody passes in a string like Bob? That can't be converted into a double. So it can't be parsed into a double. The application will essentially blow up and give the user some error. Now we'll talk about how to handle those sorts of things a little bit later, but a very elegant way to handle this situation is to use the try parse method instead of the parse method in this situation. So what you do is you still pass in the text, the string value that you want parsed, but in addition to that, you pass in what's called an out parameter. We'll talk about out parameters in length here in a couple of lessons because we'll build our own. But essentially, instead of returning a value from the method the normal way, which would be in this particular case, this is going to return a true or a false. It also returns a second value, which is the actual parsed value, taking the quantity text box.text and then parsing it into a double. So what comes out of this, you can see that we've declared double quantity equals 0.0, and then we're going to attempt to parse this string into a double. If it's successful, we'll get something in our quantity variable as an out parameter to the try parse method. Additionally, the try parse method will return a true if it was able to successfully convert the value, and a false if it was not able to successfully convert the value into a double. All right. So here we're prefixing that with the exclamation mark, which means that if we are not successful at trying to parse the quantity text box.text into a double, then we want to also return out of this event handler method. Okay. But finally, then we're able to multiply the quantity that the user typed in by, in this case, there are 2 cups in a pint. So that's the conversion that we want to do here. We get the value of cups, and then we print out the number of cups to string and into the result label.text property, okay? So that's how it works. Now, look that's the same thing that we did from quarts, from gallons. Also, if we go up here for pints, it's essentially the same equation. And so as I look at this, I think, well, it seems to work and everything, but there's just a lot of code here that's duplicated. And so what I could do is I could remove a lot of the duplication and merely call a helper method, or merely call all this code once from one place. And there's a couple of different ways that I can go about this. But this first time, what I'm going to do is create an all-encompassing calculate cups helper method to take care of all of all of these checks and everything that we're doing right here. So let's go private void. We'll explain these keywords in just a moment. Calculate cups. Then the first thing that I want to do is actually just kind of copy some of this code that we've already written, like from gallons radio. I'm just going to go ahead and copy these lines of code, these two checks that we perform right off the bat. All right. Because they're both dealing with the quantity text box. And at the end of it, we're going to get a quantity. Now, the next thing I'm going to need to do that's a little bit different than what comes after this check here in each of the event handlers is that now I want to see which checkbox or which radio button has been checked. So let's go if from cups radio dot checked, then we're going to define a cups variable. So here, let me put double cups equals 0.0. All right. So now we're going to start the cup calculation equals the quantity, because if they type in a number to convert to cups and they select the cups radio button, there's no real equation there. It's going to be a 1-to-1. All right. So let's move on to the next one. Else if from pints radio dot checked, then cups equals the quantity times 2. All right. Else if the from quarts radio dot checked, then cups equals quantity times 4, and then finally else if from gallon radio dot checked, then cups equals quantity times 16. All right, and then finally what we'll do is do the result label dot text equals the number of cups colon and then plus cups dot toString. All right. Now what we can do that we've created this private void method named calculate cups is that I can call this method everywhere where I need to perform all this calculation, and I can essentially remove most of this code. In fact, what I'm going to do, since you already have the before in your project folder, I'm just going to delete everything so you can see the full effect of this. So I'm going to select all the code inside of the cups radio check changed event handler, and I'm just going to paste in calculate cups. So you can see that I'm using this opening and closing parentheses, and that is the method invocation operator. That means find a method by this name and invoke it, all right, like so. Now, if I were to leave that off, I'm going to get a red squiggly line. It's going to say that void only assignment call decrement increment, decrement, await, and new object expressions. What's the problem? We didn't use an operator. We didn't create a real statement in code. All right. So that's how we call a method by its name. We gave the code block a name, and we're using that name now to call that code block and execute the code inside of it. So let's go ahead and copy this one more time on our clipboard, and now we're going to replace all this code again with just that, and then we'll do it again here with just this, and then we're going to do it right here with all of that. And we get one other tangential benefit, and that is before this quantity text box text change event didn't really work. We didn't write the code for it. It would have required more logic to make sure that at least one radio button had been selected. And I just didn't go through that exercise. But now all I have to do is just paste this in, and that's all going to be taken care of for me here inside of my calculate cups helper method. Okay, so let's go ahead and now run the application and ensure that it still works. All right, so I'm going to type in the number 8 and then pints, and then 8 quarts, and then 8 gallons, and then 8 cups. All right, so it still works, the calculation still works, but I've dramatically reduced the complexity of my code. I can just call it from each place where I need that code. So this is in an effort to reduce duplication. There's a principle in software development. It's called the DRY principle, or DRY principle, and that simply stands for don't repeat yourself. You'll see the capital letters DRY often used in software development and used in many different contexts. This is the most simple context in which that principle can be applied. But the benefit here is that if I were to have some problem, some bug, some malfunctioning code in one of these event handler methods, when I had 6 lines of code, 8 lines of code, it would have been difficult to find the exact error. I would have had to make a change potentially in each of these event handlers where I'm currently calling calculate cups. But now if there's a bug in my program, all I need to do is fix it in one place, and once I fix it there, it'll be applied to every other call that we make from all the other event handler methods. Okay? So let's talk about some of the keywords here you see in blue. This word private will come in handy a little bit later when we talk about private versus public versus protected accessibility modifiers for classes. All right, so right now it doesn't mean a whole lot, except that this little method is only intended for use on this web page and by no other class or code block in the rest of our application. Okay, so it's private to us. We just need a little helper on the side. Nobody needs to know about what I'm doing underneath the hood, so to speak. That's all encapsulated and private, and it's just my implementation details. All right, so that's the notion of private. The word void means that we're not going to return anything from this call to our calculate cups method. So there's no return value. Now, what does that mean exactly? Well, here's a good example of the return method, this double dot try parse. Remember when I hovered my mouse cursor over it, you can see that in the IntelliSense, it gives me a little hint here that this method will return a Boolean value. You can see the arrow pointing to bool right now. Similarly, if you were to hover your mouse cursor over the trim method, you see it's also using the open and closing parentheses. That's the method invocation operator. Notice that it returns a string from this method. Okay. Furthermore, if we were to look at this other method down here, because it has the open and closing parentheses, I know that it's a method. It also returns a string. All right, so in this particular case, we're not going to return anything. We'll talk about returning values, returning data in an upcoming lesson in just a lesson or two, okay? But for now, this one's not going to return anything. It's going to be silent about its work. So you're going to call it, it's going to do its thing, and you don't expect it to reply with any information back, okay? You're just going to call it and then move on to the next line of code. All right? So I think that's all that I wanted to say in this lesson, and we'll talk about the variations on this idea, like how do we send values into a parameter, into a method by using input parameters? How do we retrieve values out with return values and so forth? And we'll talk about that beginning in the next lesson. See you there. Thank you.